have a fellow who criticized my notion of the scientific method. Can you believe that? Criticizing the scientific method, the real scientific method, okay? And give me a second here. Let me remove this. Okay, and so he's what I call a science critic. Okay, and what he's going to complain about is he says that you can understand physics, right? Physics or physical mechanisms or whatever. You can understand them, but you don't have to be able to visualize them. In other words, he doesn't relate understanding with visualization. Okay, and I say more or less the opposite. I'm saying that in physics, physics is about mechanisms. And if you cannot visualize it, if you cannot make a movie of your mechanism, you did not understand it. Okay, so that's going to be the issue. Let me put him on so that you can hear from the horse's mouth. Okay, give me a second here, and here goes. Listen carefully.
The issue to be addressed in this rebuttal is, if you cannot visualize a mechanism, have you understood it?
So it's not really about visualizing it, it's about understanding it. Yes, visualizing it can help, but it's not the be-all end-all. If you can't visualize something, but you can understand it, then that's more important than being able to visualize it, but not being able to understand it.
Okay, we got it. That's the issue before him today, the subject matter today. And let's start with what science is and what science is not, because that's, I think, where the problem starts. We have to go all the way down to science and find out what is science about. Yeah, I think that's where the issue is. Okay, so here we go. Science, according to this site, our channel, right, is about explaining rationally and only about explaining rationally. What is the definition we have? Rational explanations. Very simple, very straightforward, not wordy, very concise. Very difficult to challenge because it's concise. On the other hand, what you have today, is this notion that people have that of what science is, or in their minds, okay, what they think science is. They think it's about observing, studying, running experiments, making predictions. I forgot to put in there, this just came out of the top of my head, the fact that they use math and equations, okay? That's got nothing to do with science either. We don't do, why? Because math is about describing. Math can only describe, an equation can only describe, so that's not part of science. We explain, we do not describe. Anyone can describe a chair, okay? Not everyone can explain, how gravity works, okay? So that's where you have to break your brains, okay? Voting for theories, we do not have democracy in science. We do not also have tradition. We don't say, well, that's the way we always did it. If it don't work, meaning in science explanation, you cannot explain, then we have to change it. We have to do something about it. It's broken. We have to fix what is broken. Okay, and we don't do winning prizes, none of that stuff. Okay, so what is instead science? Okay, well, there you have it. And here you have the mathematical method as we call it. This is what we inherited from the people in the 17th century, so-called scientific revolution. It's which is really a method of research and persuasion. What they did is include things on how to do experiments in your little dark basement. You do research, you do study, you put your brains to work, no problem there. But then, when you have to come to the conference, what you have to do is explain what you learned. Instead, they emphasize and harp on persuasion. They said, let me convince you. Let me show you proof. Let me show you evidence. No, that's not science. Okay? And so they have all these steps in the so-called mathematical method here, Observe, explain tentatively, which they call a hypothesis. They do predictions, they do experiments, they describe mathematically, and they call it a theory, which is not a theory. A theory is an explanation, not a description. An equation is not an explanation. Okay? They invent technology. They think that with that they confirm the theory. They convince other mathematicians. They talk about truth, fact, knowledge. We know. You don't know, we know. Okay? And we proved it through some experiment. Okay? And then they verify through measurement. In other words, someone else tries to verify your measurement, especially your description, your mathematical description. And if they confirm it, then they were not able to falsify it. There's no falsification of your theory. And as long as it's not falsified, that means that you can continue rolling and believe it. It's about belief. Then they win prizes and they do the celebrity circuit. That's essentially the method today that they have out there. And now we're saying that's not science. Science is rational explanations. Specifically, it's related to physics, which is what we do here. Okay, so what is physics? Well, here we have it. This is gives you an idea of what physics is, okay? Well, first, we have it here. Those who have a different version of this scientific method, the one that we propose, rational explanations, well, they have a single recourse, okay? And that is to propose a definition that they can defend, okay? And so they should be able to use it consistently. And then if it's worth anything, their scientific method or their version of science, they should be able to explain how the universe works, the things we are interested in explaining. We want to know how gravity works. We want to know how magnetism works, how light works, how the atom works. This is what we, and by how, I don't mean describe, I mean explain the mechanism. What is the cause? That's what we're talking about, okay? And if you're going to define it, if you're going to challenge the definition, rational explanations, right? If you're going to challenge that definition, well, the more things that you add to your definition, you make it, a big paragraph, 200 words, 500 words, right? The more words you put in there, the easier it will be to destroy your notion of science, okay? Because you will not be able to apply it consistently the more predicates you include in there, okay? So that's something you got to keep in mind if you're going to challenge the definition. And here is, the version we have today of science. It says, there is currently no consensus regarding the definition of life. This is an example of why, you can't put too many predicates in there because it's easier to tear down. And I'm giving you an example here in the word life. Okay, nobody has been able to define the word life. In other words, no biologist on planet Earth has any clue how to define the word life. Okay, they never defined the word, but they're all biologists, which is the study of life, according to them. Okay, and so you have one popular definition. This comes from the Wikipedia: is that organisms are open systems that maintain homeostasis, are composed of cells, have a life cycle, undergo metabolism, can grow, adapt to their environment, respond to stimuli, reproduce, evolve, etc. Right? Okay, great. Okay, so it says there, for example, let's see. Let me pick one out of here. Reproduce, for example. Well, my grandmother doesn't reproduce anymore. My aunt never reproduced. Were they alive? Okay, can grow. What if you don't grow anymore? What if you shrink? Does that mean that you're not alive? So you can see how easy it is to tear this definition down because they put so many predicates, so many conditions for defining the word life. And that's the problem when you define the word science. The more words you put in there, the tougher it's going to be for you to defend that definition, because you're going to have to be able to apply each one of those predicates, each one of those conditions, each one of those specifications to whatever challenge you receive. Okay, so that's why, all my definitions are very short. It makes it hard for someone to attack it. And it's got to contain the essence. In fact, all definitions should be that form the foundations of science, of physics, of philosophy, have to be very, very short as you can make them. Get rid of words. The more words you put in there, the easier it's going to be to tear down. Okay, that's my rule of thumb for you. Okay, take it or leave it. Okay, and here we have the word physics. Okay, which we want to define. This is what we do here. Okay, science is divided into two categories, and one of those, and only two categories. Okay, one is physics, the other one's philosophy. Okay, we're going to deal a little bit with philosophy today because we have this issue of the multi-universe. Okay, and so what is physics? Physics, the branch of science that attempts to explain mechanisms rationally. Rational explanations of what? Of mechanisms. That's physics. And philosophy is rational explanations of behaviors in comparison. Okay, and specifically gravitational and electromagnetic phenomena. That's what we want to explain. That's what remains out there. We've been able to explain everything we can see and touch that we're more or less familiar with. We have not been able to explain in the last 3,000 years that which we cannot see, that which we cannot touch. That's where the problem is. They have not been able to answer that, and what they do is do a lot of math, and then they give you an irrational explanation, and then they say, well, that's not important anyways, that's just philosophy opinion, and that's what they call science, that they gave you a mathematical description in lieu of an explanation, okay? And so again, the more predicates you introduce, the worse it's going to be for you if you're going to define the word physics, okay? So we say rational explanations of mechanisms. That's very short. How do they define it? I think I have it here. This is the definition from the Wikipedia, okay? Physics is the natural science that studies matter, its fundamental constituents, its motion and behavior through space and time, and the related entities of energy and force. Okay, so you can see a quite lengthy definition or notion that they have today. And what's the problem with it? Well, energy and motion and force are concepts. Physics does not study concepts. That's probably where it all falls apart. But it talks about, actually they're referring to descriptions, but they say it studies. No, physics doesn't study anything. You could be studying anything you want, okay? And that doesn't mean you're going to learn. That doesn't mean you understand something, okay? So studying is not enough. Even children study. Is a child who studies in kindergarten, is he or she a scientist because she studies? So studies alone does not do the trick. You can study all you want. When you come to the conference, we want you to explain what you understood, what you learned, Share with us your intelligence. But if you just say, I studied, and then you got a 0 on the test, well, what was the point of studying? I mean, prove that you studied. And the way you prove it is by explaining. So, no, to say that you studied, and it says studies matter. Okay, so you studied matter. What did you learn? Fundamental constituents. Okay, what are the fundamental constituents? Space-time, is that a fundamental constituent? Energy, mass, force, time, are those fundamental constituents of, the universe? And then it says it's motion. Yeah, we do try to explain motion, but motion of things that we can see is no problem. The question is motion of that which we cannot see and touch. Okay, that's where it falls apart again. Okay, and again, behavior through space and time. Again, we don't go through space or time because neither time or space are physical mechanisms. They're not containers. They're not media. Okay, so you cannot say that you go through space or you go through time. Okay, so whatever through means in this context here. No, we don't go through space or through time. You can't say you go through space or through time. Not in physics. Maybe in some kind of religion out there, mathematics. Then you can talk about going through space and time. Okay, so here we have a case for this gentleman who says that a mechanism, you do not have to visualize it. You can just understand it. And we can say, no, if you cannot visualize it, you did not understand the mechanism. And this poor fellow, he doesn't understand that. Okay, so here we go. Let's give him an example. I'm going to show you something that happened. Okay, it's going to be window breaks. Very simple stuff. Okay, and I'm going to show you that first. Okay, here it goes. We have something going through the window. It's known as a horseshoe. And here we have good old Felix the cat. He revolves it and throws this horseshoe. Okay. So you can see how it broke. Okay, so if you ask anybody, okay, what did you just see there? And they would say, how did the window break? Well, how did the glass end up on the floor? Well, I think everybody would say the same thing. Say, well, there was a horseshoe thrown and hit the window and broke it. Very simple. Okay. Okay, now what if we do it this way? Okay, here we have it. And this guy just waves his arm. Did you see what broke it? Can you tell me exactly how the window broke now? Now that you cannot see the mediators? Okay. All you see is a guy waving his arm, okay, and then the window suddenly breaks, like by magic, remote control. So how do the mathematicians do it? Well, they give you a description. They say something like this. Okay, they say that you got this force that goes through the window. Okay, they use all these mathematical concepts. So they say, look, he waved the mass, okay, and with all this energy, right, and the force went through the window. That's the kind of answer you get from a mathematician. Well, so far you have no physical interpretation for how the window broke. You cannot use these words to explain how the window broke. The way you say it is you say a horseshoe went through the window. Okay? And we do not need to know the resistance of the glass, none of that nonsense that people get into. We just need to know how the window broke, and it's very simple. The mechanism is horseshoe went through window, period. Tarzan-like. Okay? That's how you explain that. And you do not use these words such as mass, energy, or force. Okay? Let me give you another example, okay, just so we know that you have to explain, if you're going to explain a mechanism, you have to put objects in front of the eyes. So you should be able to illustrate it. The language of physics is not mathematics, energy, mass, force, all that time, all that nonsense. The language of physics is illustration. You should have objects in front of my eyes so that I can see the mechanism, and just by watching the entire show there, I can get an idea of how the window broke or whatever mechanism you're trying to explain. Okay, that's the point. So you should be able to illustrate, you should be able to visualize the mechanism in order to say that you understood it. Otherwise, you can't say, well, I can't visualize it, but I understood it. No, you're lying. You're kidding, or you're fooling yourself. You thought you understood it. You can't visualize it. The mechanism, you have not understood it. In physics, you need to visualize. Okay, and so here's another example. Okay, and here we have it. We have a pulley. Okay, and it's pulling on a box. Very simple stuff. Okay, so you ask, how did the box go up? Very simple stuff, okay? And you say, okay, someone pulled on the rope, and it was wound around a pulley, and which was also tied to the box, and, that's how the box went up. We can all explain how the box went up because it's all connected. Okay, now let's do it the invisible way. Okay, suddenly the box goes up. Okay, and you say, well, how did the box go up? Was it magic? I mean, now we don't see the mediator, which in this case was the rope, right? And suddenly the box goes up and it's very scary because you cannot explain it. Why? Because you cannot see or touch whatever is pulling the box up. How do the mathematicians do it? Well, this is the way they do it over there. They say, well, there's this mass and there's a force that's maybe pushing it from below because they don't see anything there. And say there's so much energy involved, okay? And it went up in so much time, okay? So far we haven't answered the question, what is the physical mechanism? And so you say, well, I cannot visualize it. I cannot make a movie of it. All I can do is describe it with all these mathematical terms. There's so much force, and they give you a number followed by a unit. There's so much mass, number followed by a unit. So much energy, number followed by a unit. So much time, number followed by a unit. That's what they give you. And they say, well, yeah, there's a force pushing up the mass with so much energy, and it took so much time. That's the kind of answer you get. And you say, well, what's the mechanism? How did the box go up? What caused the box to go up? And they have no answer for that, okay? And so the question is, what's the mechanism? And so they say, well, maybe it was warp space. The warp space pulls it down, or warp time. Usually it's warp time. Okay, they pulled it down, and so the box is pulling against it. And you still don't know what's pulling it against the warp space. Okay, what's causing the box to go against warp space? You still have no mechanism for what's pulling the box up. And so, unless you can illustrate the mechanism, okay, you have not understood it. All you can do is describe it and say, mathematically, in this case, you say, well, there's so much energy, so much force, so much mass, so much time, or whatever other parameter you want to put in there. But you have not been able to explain it. So this fellow says that, you can understand it, but not be able to visualize the mechanism. And the answer is no. If you cannot make a movie of your theory, of your mechanism in physics, you have not understood it. You have to put physical objects in physics. Physics, first and foremost, is you need an object. You can't do physics without an object. You need something there. For that, you need to find the word object.